Okay, and if I say so yesterday you understood, right, how we were like creating containers. Did you try to see the differences between your images and containers? Did you got like clear idea what is image, what is container, right? Can anyone tell me like can I create what do you say? Uh, can I change my image? Can I change an image? Let's say I'm having containers and images, right? Can I stop image? Can I stop image? Is it possible to stop image? Yep. How is it possible? We got two things, right? Containers and images. You can stop containers, but not images. Images are like your templates, right? You got some templates. If you want to run specific template, that is where you use the concept of containers, right? Containers are like your classes. I repeated yesterday, right? So basically, if you want to start, stop, or remove, it's possible. And removing images is also possible, right? So let's see. We'll go and control the container today, right? Yesterday when I was creating one specific container, right, I was by default, what is happening, let's say if I run any specific container, right, if I'm saying like this, what is happening actually, what happens in this particular scenario right now, if I run this command, what is going to happen? It runs in the background, right? If I run this, you see a particular container has been started, and if I say docker ps, it says that one particular container has been started around like 6 seconds ago, right? Now basically what is the meaning of this specific thing means, you got template called CentOS, right? From that from the template called CentOS, you created one container, right? And currently how you can go and log into that container? Docker, right? Container id or container name followed by, right? And can you see this is something like host name, or let's say whenever I was creating that specific container, I was not able to control that container, isn't it? You see these names, nothing is being controlled by me. So when I want to control, right, that is where we can go and modify these container settings, right? What I'll do is like now, let's say docker stop, so I'm going and stopping that specific container call which we created earlier, Thursday something like board. It takes some time, stop. All right. Now if I say docker ps, nothing is running in the backend, right? Now what I'll do is like, I'll start the container, but I want to give my own name to the container. Earlier, what is the name which got it created? Something like thirsty board, which is some random name, right? Now let's say I want to create my own container with my own specific name, right? You'll say docker, right? Run. You need one more particular command. I'll say hyphen hyphen rm. I'll talk about this command, what it does, right? So I'm running hyphen hyphen rm. Let's say I'll start it in the interactive mode, right? And what we did yesterday, we have given something like CentOS and bash. This is how I started yesterday, right? Actually, don't even have rm command yesterday. This is how we ran yesterday, isn't it? Now I am going to give hyphen hyphen rm. So what is the meaning of hyphen hyphen rm here? It is, so whenever you are stopping your container, or let's say whenever you are exiting from your container, what is happening to that container? whenever I stop that container, what is happening? It is just going in, what do you say, it is going into the history basically, right? But it's not removed from your system, right? So Docker, let me do something like this. Okay, I'll stop it here. If I say Docker ps, what is this command giving me actually? Yeah, I mean, like, basically it is giving me the containers which are running, right? Containers which are running. Now if I give ps hyphen a, all the containers which were stopped, whether they are running or not running. You see, I actually started like around 4 containers from yesterday. These are in the exited state, they are stopped. If you want to remove them, so whenever you are stopping the container, right, you can remove them with the option of hyphen hyphen rm. If not, you need to go in the backend. Now if I want to remove, right, docker container rm, the container name, this is how I need to remove it up. Now again I need to say docker container rm. లేదు బ్రో, అదే అంటున్నాను, బ్యాక్ ఎండ్లో రిమూవ్ చేయాలంటే ఇలా రిమూవ్ చేయాలి. మీరు ఆన్ ద ఫ్లై రిమూవ్ చేయాలంటే వీల్ గివ్ హైఫన్ హైఫన్ ఆర్ఎం ఆప్షన్. ఎప్పుడైతే ఎగ్జిట్ అయిపోయినప్పుడు ఆటోమేటిక్గా డిలీట్ అయిపోవాలి కంటైనర్, ఆటోమేటికల్ ఇట్ షుడ్ రిమూవ్ ద కంటైనర్. అప్పుడు ఇచ్చే ఆప్షన్ హైఫన్ హైఫన్ ఆర్ఎం. మీరు మాన్యువల్గా చేయాలంటే ఖచ్చితంగా ఇలా చేయాల్సిందే, యూ డోంట్ హ్యావ్ ఎనీ అదర్ ఆప్షన్. సో మీరు బ్యాక్ ఎండ్ నుంచి వెళ్ళి మళ్ళీ యూ నీడ్ టు రిమూవ్ దిస్ వన్. అగైన్ యూ నీడ్ టు సే, సో ఇఫ్ ఐ సే డాకర్ పిఎస్ రైట్ నౌ, running containers, there are no running container. But if I say ps hyphen a, you'll only see 2 options. Why? Because I removed the earlier 2 options. Hyphen hyphen rm ఎందుకు వాడుతున్నాం అంటే బేసికల్లీ స్టార్ట్ చేసినప్పుడు ఎప్పుడైతే ఎగ్జిట్ చేస్తున్నారో ఆటోమేటికల్గా ఇట్ విల్ రిమూవ్ దోస్ కంటైనర్స్. దానికి హైఫన్ హైఫన్ ఆర్ఎం. ఎందుకంటే కంటైనర్ మీకు ఎప్పుడైతే ఎగ్జిట్ అయిపోతుందో ఆటోమేటిక్గా డిలీట్ అయిపోవాలి. టెస్టింగ్ పర్పస్కి బెస్ట్ ఆప్షన్ hyphen hyphen rm, right? So once I run this, okay, if not, what I'll do is like, so if నేను ps hyphen a కొట్టినప్పుడు only I am getting 2 things, isn't it? సో జనరల్గా ఇప్పుడు నేను కంటైనర్ స్టార్ట్ చేసి ఎగ్జిట్ చేస్తే మళ్ళీ 3 వస్తాయి కదా నాకు, రైట్, వితౌట్ హైఫన్ హైఫన్ ఆర్ఎం ఆప్షన్. If I go with hyphen hyphen rm option, I don't need to manually go and delete this containers. That's what it says, right? So I'll say docker run, right, let's say hyphen hyphen rm, right, hyphen it, interactive terminal. Now what I want to give is, I want to name that container. So earlier it is generating random names, alright. You can give hyphen hyphen name. What name you want? Let's say first underscore container. What is the image you want to use? Let's say we use CentOS, right? Today we'll use Ubuntu image, right? How you will say? But did I download this Ubuntu image? Automatically it will download itself. So you don't even need to download the images by default, right? It will automatically fetch it from there, and you want to run it with the bash, right? Now if I run it, you see it was not able to find that locally. It is fetching from your docker registry. What is your docker registry? hub.docker.com. That is where all your images are stored. So it says downloaded, and it even started that particular thing. Now if I say docker ps, okay, I already logged in, right? Sorry, because I have given hyphen it. Now if I go and say docker ps here, it went, it took our own specific name. But whereas earlier what happened, it was going with some random names. Got it? Now if I stop, right, it will automatically get deleted. You see what I'll do? I'll simply say, Yeah, hyphen rm. That's the reason why. If I say exit, you see it exited. And if I say docker ps hyphen a, do I have that first container? By default, it went and it deleted by itself. That is the option of hyphen rm. So whenever you are testing something and you know that that particular container is not useful for a very long time, you can directly give that hyphen rm option, delete straight up. Right? So similarly, like you can go and do lots of things. Now, whenever I am going and starting specific containers, let's say I'll run this again, right? So basically, what is the host name if I say, sorry, it is taking the container ID. By default, your host name is set to container ID, right? If you don't want, you can go and control this aspect as well. So how you can control? So basically very simple. So let's say I'll exit from here, right? While creating only, I'll tell what is the host name I want to use, right? Hyphen, simple, right? That's it. Hyphen host name. What is the host name I want to give? Let's say this is my Ubuntu machine, right? The host name I want to give for that container is Ubuntu. So once I run this, right, I got my host name was set to Ubuntu by default. Alright, so like this you can go and basically specifically say like you can set any specific name you want or host name you want. You can go and do all these kind of configurations, right? So if I say right cat/etc os release, it says it is your Ubuntu machine. Understood? And one more thing you need to understand. So whenever you are working with your images, right? Your image is a read only. Whenever you are downloading your image, right, into your system, that image is a read only. Sorry? No, you cannot modify images. You can create your own image. That is possible. Yes, with your own configuration. I'll show you that at the particular end of our course. I'll show you how you can create your own image and put whatever you want in it. So Docker containers run on a concept called copy on write. Copy on write file system. So how it works is, so what is this particular image currently has? Ubuntu. So what this container will have generally? It is nothing but it's a copy of Ubuntu, isn't it? Now, if you do something here, let's say I'll do, so I'm already root, right? Let's say apt get update. Now you see it went and it is updating some packages. This is not happening on your image. Where it is happening actually? Container. Your container has edit access. Now you can make this like your own image. Now this particular container, does it have Apache? No, right? It is a dummy system right now. Now if I say sudo, no, I don't need sudo. Apt get, I'll say install Apache 2. What are you doing now? You are adding something extra. So what was their first thing? So first you are having only base Ubuntu container. On top of Ubuntu, you updated the apt-get. On top of that, you are installing Apache. So you can have the access of editing your containers, but not images. If you want an image which has Apache installed, you can create your own image from here. That is what your copy on write file system means, right? So you are basically creating your Ubuntu machine, right? This is one container, right? On top of it, you are putting some update. On top of it, you are installing Apache. Copy on write file system. Now, whenever your Docker, say whenever I was pulling some new image, right? It says something called like pulling layer. Did you observe it? Pulling layer. Nope. Let's see. It's not what I'm doing, right? Okay, I'll show that. First, let's say whenever I mean like you got the concept, right? What is the meaning of copy on file system? I mean like copy on write. Basically, on the specific container, you're adding new steps which you require, right? So what I'll do is like, let's exit from here. If I exit, what happens? Automatically, it will get removed, not stopped. Difference between removed and stopped is a lot, right? So basically, removing means you're basically removing that container only, right? Now, let's say Docker images ls. Right, you're currently having two images. One is Ubuntu and CentOS. Let's say Docker image rm Ubuntu. Right? You see how many deleted, it went and deleted this thing, right? Now I'll say Docker pull Ubuntu. So even, I mean like if you run also the same thing is happening. Automatically it is pulling the Ubuntu image. You see it is pulling some layers, 47 MB. Right? After that it is pulling one more change. So what is happening here? That actual image was built on 3 or 4 steps like this. It is pulling each and every specific change. So actually how your Docker images are built, you know. So let's go to the browser. So what is your Docker hub? Hub dot. If you take any specific images, right, your images are built on top of a file called Docker file. You have something called like Docker file. So let's say Ubuntu. If you go to the specific file, any specific thing you say, you have something called like Docker file. If you click on this is how your Docker file is built. So it is happening actually. So it is going and doing these kind of things over there. This is how your Docker, this might confuse you. If not, I'll show you simple things. Let's say Nginx. Very simple thing, right? Now if you go to this Nginx, so how this particular thing is built with the help of Docker file, you can see. You see, it is using a predefined image called dbane already. On top of it, what he's doing, you see, it is updating it. Then he's going and you see, he's going and getting that dbane packages. You see, he's putting that in your particular location. He's changing the permissions. Then at the end, you see, he's running this particular thing. He says Nginx, this particular command, and it should run on port number 80. So that is how your Docker images are built. So when you want to build your own image, you will write Docker file. So I'll show you. Let's say when you are working with something, I told you, right, I'll show you even how the Node.js applications work. With the help of this particular Docker file, we'll create our own image where your project would be running on the fly. So whenever I start a container, my project should be up and running. Right? That we need to go and develop our own Docker file in such a way that it should start all this particular process and do all these tasks. We'll see that. Fine. So you understood, right, where your images are actually created from? Fine. Making sense? Very important. That's how your particular images are done. And you got, right, what's the meaning of copy on write file system? That is also clear? Good. Any doubts in that? Are you confused? If not, if you are confused, just straight away let me know. We will repeat it. No problem. Right? Can we repeat that thing? Okay. So let's say whenever I am running this particular, what do you say, pull command. So what it does, it first goes and checks your Docker file. What is there in the Docker file? It will go and grab all those things. Those are nothing but your each layer, changes which are there in your Docker file. Consequently, it is pulling those changes. Right? After pulling those changes, you have your own image within your particular system here. Right? So all these images, it is going to store under your local repository. So Docker has its own local repository. You have something called like var lib docker, where all the Docker cache is stored. Whenever you are starting a container, right, it is going to that image, it is taking the image template, it is starting one kind of container. Here container is like basically your virtual machine only. Right, you are getting all the features which are there in your same virtual machine. Isn't it? Now basically this works on the concept. I mean, like how your containers work is nothing but they use something called like copy on write file system. Right? Images are not like that. Images are only a read only. Right? Whereas containers you can go and modify anything you want. If you want your own specific image, right, on top of this specific Ubuntu image, you can create and do anything you want, and you can make it like your own image. That is possible. Right? Got it? Fine. Now what I'll do is like I'll show you one particular important thing. So Docker works on something called like persistent. Your Docker containers are completely persistent. I mean, like basically you can say that they are very volatile. Docker containers are completely volatile, meaning in the sense whenever you work on containers, if you store some data in your containers, right, whenever you are storing some data in your containers, once you remove the container, whatever the data which you stored in that container is gone. Very important thing to remember, right? So if not, I'll just put it up. Right? Containers are usually immutable. You can say immutable as well, right? That's the meaning of immutable, right? Immutable, and basically immutable you can say that you can call something like ephemeral, right? Which means basically temporary and disposable. The same word you can say either temporary or disposable, right? So why containers are very lightweight? Because they are very easy to remove, isn't it? You are just like going and removing containers like anything not happened at all, right? And one more thing, so I told that they are temporary. So if the container is temporary, whatever the data you stored in that container is also going to be temporary, isn't it? because this container is acting like a VM for you right now. If you remove the VM, are you going to have the data? Right? So let's say you created some Google Cloud machine. You kept some WordPress directory over there. Once you remove the instance, do you have the data? The data is gone, isn't it? It will get erased. Similarly, your Docker containers do the same thing. If you remove the container, the data which is there in your particular container is gone. So let's see one small particular kind of example for that. Now let's say I'll go, what I'll do is like, right, okay, and I'll not say hyphen rm right now. So I'll not remove it straight away. So I'm going and creating something called like a first container. Alright. Right. I am currently under root. If I say ls, yes. Now what I'll do is like echo something like Ravi, and I'll redirect it to something like ravi.txt. So what it is going to do? It is going to create a file called ravi.txt and it will put the content. Now if you see, yes, I have a file called ravi.txt, right? If I say cat ravi.txt, yes, I have that specific content. Now if I say exit from this, what happens actually? Right, exit. So what is basically does when I do exit, what is happening to the container? It it stops. It stops first thing, right? If I say docker ps, is it running? No. But if I say ps-a, it will list because you just stopped it. You see first container. You stop the container. Now you want to go and start that particular container. What you'll say? Docker container start and the container name. Let's say first container. Right. It went and it started. If you say docker ps again, ఆ కమాండ్ ఫస్ట్ కంటైనర్ అనేది ఒకటే రన్ అవుతుంది. స్పెసిఫిక్ ఐ మీన్ లైక్ ఇట్ ఈస్ గుడ్ ప్రాక్టీస్ యాక్చువల్గా కంటైనర్ అని ఇవ్వడం. ఇప్పుడు నేను కూడా డాకర్ రన్ అని రన్ చేస్తున్నాను కదా, జనరల్ ఇట్ ఈస్ గుడ్ ప్రాక్టీస్ టు గివ్ డాకర్ కంటైనర్ రన్. Right? Anything is fine. You can go with that. This is a new notation how they are going with docker container run, docker container start, docker container stop. Right? So I'll say I started this thing. Now if I say docker ps, yes, my first container is running up. So how I can go and attach to it? Docker. Yesterday we tried it out. Execute, right? Because that is started, but you are not in that container, isn't it? You can say docker execute -it. What is the container? First container, right? First container. Now I'm in my Ubuntu, right? If I say ls, do I have ravi.txt? Yes. If I say cat, yes, it's there, right? If I remove that container, let's say I'll exit from here. Now if I say docker ps, it is still running, right? Now what I need to do, I need to stop it up. Docker container. So you can automatically remove it forcefully as well. I'll say docker container rm -f forcefully. Stop and remove it automatically. I'll say remove this specific first container, right? It got removed actually. Now if I say docker ps, nothing is there. Even if I say ps-a, first container is also gone. Now what about that file called ravi.txt? There is no way you can get that file. 100% no way. That is what I am talking about. Containers are temporary. The data is also temporary. Right? Very, very important thing to notice. So that's the reason why containers are called very volatile or persistent. Right? So to basically avoid this problem, we got two options. One is called Docker volumes. Docker volumes, very important concept actually in Docker. So this disadvantage can be overcome by something called like Docker volumes, and you have something called like data mounts or bind mounts. Basically you can say like bind mounts. Yeah, bind mounts. So you got, so let me put up this file. So you understood it. So basically, to solve this, we got Docker volumes and bind mounts. So you can use these concepts. MOUNTS. Sorry, mounts. Yeah. Right. So when you are working with volumes, right, two things you need to remember. So when you are working with volumes, right? So what is the main purpose why you are working on volumes? What is the advantage I am getting with volumes? What is the disadvantage of container right now as of now? Right. So when I remove that particular container, data has been lost. Docker volumes actually came to avoid that problem. So basically what it says, to keep data, right, uh, around when container is removed, right? And one more thing you can do, to share data between host, right, and container. What is the meaning of sharing the data between host and container here? What is my host? Yep. So you can say that that is your particular host. So what is my host here in my Google Cloud? The virtual machine which I created, isn't it? Docker 5pm. If you have some data on this Docker 5pm machine, you can share that with your containers. If not, whatever the data which you kept in your containers, you want it to be available on your host machine. Making sense? No? So let's say, so what was our particular implementation? So let's say, this is your language which you implemented, right? So this is your language machine. You install Docker service on this. Isn't it? So what you are creating actually? Containers, right? Let's imagine this is one particular container, right? What is happening? Let's say I stored some racket.txt. So whenever I am removing this container, what is happening? Whatever the data is there, it's gone. With the help of Docker volumes, right? What you are going to do is like you are going to share, right? I mean, like you are going to save this file on your host. I mean, like your this Linux machine. So what happens if I remove this container? Even container only removed, but we have data example. Basically, you are going to have your file. So what is the purpose of containers actually? Why we are creating purpose of, I mean, like containers? Reduce the size, reduce the processing, right? Basically, what is the I mean, like advantage actually? So let's say you're telling like reducing the size and all this. But why I'm going for Docker is actually, if I want some particular software, I don't want to do all these pre-implementations, isn't it? That is a major thing, right? Now, why you need basically Docker is nothing but your processing machine. If you store data, we know if container is removed, everything is gone. At the end of the day, you will never store data in your containers, 100% sure. At any chance, you are not going to store the data. Where is data? On the host machine. Even if your container is removed, when you create a new container, if you give the data, right, it's all set, isn't it? Now let's say imagine you created some Nginx container. What is the main purpose of Nginx actually? To serve the web pages. If you keep the data directly in the Nginx server, what happens? I mean, like Nginx container, if the container is removed, the website is also gone. Now what you do is, right, you keep your website data here on host machine. What you say, git clone to this machine. You got your entire website here. When you are running this container, you will say take data from there. But this is not going to be hard coded thing. It is something like a soft link. Now if you remove this container, what happens? Just the processing is gone. Do you lose your data? What you will do again? You will create a new container. You will say take data from here. That is the actual purpose of Docker. So now let's say you want to upgrade some software. What happens generally if you upgrade? Your data is generally lost. Right? Let's say when you are setting up your Android mobiles or something, if you are hard reading setting, right? Your data may be lost, isn't it? Whatever the particular free applications, everything you install. Why? Because data is hard coded. Now what you are doing, even if you reset, delete, do anything, once you create it back, if you have data, everything is safe. What is a major component in your applications as well? Database is a major component, isn't it? All the data is going to be stored in your database. If you keep your database intact, even if your application crashes, whatever may it happen, you can get the data back because you have separate database storage. That is the purpose of database, isn't it? Similarly, your containers will also use volumes. Got it? The purpose of volumes actually? Sure, 100%. Very important. In Docker, if you create volumes and data mods, that is where you are very, very careful you should be. Because if you don't know about this concept, right, even if you create hundreds and thousands of containers, it does not make any sense. Without data, everything is at risk. That is where volumes comes into the picture. Yes, simplified system. Same thing in Linux we have. So basically, in data modes, it becomes much easier. Volumes is somewhat typical to do understand this kind of thing. After volumes, you got data modes. Data modes is very simpler, more advantageous than volume. So I'll show you like volume as well. Then later I'll show you data modes. Data modes is very simple. Volume is somewhat typical. It is even tough to remember. But whereas your data modes, in seconds you can grab that particular concept. Yeah. Yeah, so I'll share few of the points. Already, you can take these particular points. Very important things to remember when you are working with Docker. These are the particular things you need to remember about volumes. First thing, this particular thing. These 3 points are very important. So first thing it says a Docker volume is a specially designed directory, right? And it is says it is initialized when the container is created, and by default it is not going to be deleted when the container is stopped or removed. And you can say this already. So you can say Docker containers volumes can be shared across containers. These 3 points you should always remember when you are working with volumes. So instead of stop, you can directly say remove. You're not feeling well? We'll go for like 10 minutes and we'll stop it. Right? So these are very important 3 points to remember when you're configuring volumes in the Docker. Right? Alright. Now you see how we can create the volumes. Now you've got a command called docker volume ls, docker volume list. This would give you the list of volumes which are there. Currently, do you have any volumes? Because we did not create any volume yet. Right? We did not create any volume yet. Now let's see how you can go and create your own volumes. Very simple. You give specific tag called -v, done. Volume is created. Now I'll say simply docker, I'll say container. So basically this is how you need to create the container. I'm directly giving run, but you can say docker container run. I'll say -it, right? Let's say hyphen name. Let's say this is my second. I'll say this is my name for the container second, and I want to give some specific volumes here, right? I'll say -v volume, and I want to create a volume called something like, I want to mount it in the root directory, root of container. When you log into the container, right? Root of container, right? Let's say something like, I want to keep something like data, right? And what is the image I'm using? Ubuntu, and I'll say bash. Same thing, right? Just we added something called like -v option additionally, right? If I run this, see, okay, I have given -it, that's why it directly went and logged in there, right? Interactive terminal. So if I say docker ps, yes, I created the second container, and if I say docker volume, so it created some volume with some specific ID over there. Now if I go and log into this system, and if I say ls, can you see I created that particular thing called data. Now whatever I am updating under this data, it would be there and stored under this volume. Got it? Now how it is going to store actually? I told you that volumes are going to store on host or container? Host machine. They are going to be stored under the host machine. So you need to know, right, where it is going to store. So you got one very important command to remember, Docker inspect. If you know this particular command, you can go and do anything you want. Docker inspect command, right? Docker inspect, and what you can inspect? You can inspect the container. Container ID or name. Docker inspect, you need to say container, and what is the name? Second. You can give container ID or container name, anything is fine. Docker PS. If you remove that, right, how are you going to have container? Okay, you want to know the volume if the container is removed. You will say, what is this one? The volume, right? Now you can say Docker inspect volume and the volume ID. So I'll show both the things. First I'll show the container. Let's say if container is removed, how you can go and take the data, right? If I say Docker inspect container, container name, this command will give you A to Z information of that container. You see that container MAC address, its default gateway, it has its own IP address internally, right? It has its own network ID, because this is your network settings. It is like your VM only at the end of the day. Like I told you, right? Container is nothing but it acts like a VM, which is disposable and lightweight. Now it has got all the information. It has its own gateway, and if you go right, it has its own network settings. And you see, I'll just like scroll it to the top. You see, it says this is the idea of that particular thing. This is where it started, and if you go, this is what the image you used to start it. This is what the name you have given. It collects every information, and if you go down here, and this is a volume ID, isn't it? A67D703. If you go and check it here, okay. If not, I'll open one more session, and I'll say Docker volume ls. You see, A670 something 703, and if you compare it, and where it is source, this is where it's stored in your host machine. If I copy it up, and if I go here, and if I say ls, okay, it says permission denied. So currently nothing. Why? Because do you have anything there? What I'll do, I'll go to this container, I'll say cd data, nothing is there. Let's say touch ravi.txt. Now if you say, I got a file called ravi.txt. If I go here, if I do again, making sense? So volumes is very important. Volumes is a particular thing which attaches this data to your containers, and even if you remove these containers, the data will be still intact. If you remove the volume, it's gone. Making sense? If you remove the container, data is going to stay with you, but if you remove the volume, data is going to go. So what I'll do is, like, now I'll remove this particular container. Let's say what I'll do, I'll quit from here. Sorry, not this one, right here. Right? I'll say I'll quit. Sorry, exit. Right? I'll exit. Now my container is stopped. If I say Docker PS, it has been stopped. But what I want to do, I want to remove that container. Docker container rm second. It has been removed. Now if you say Docker PS -a, nothing is there. Right? But what you have? Volume. If I say Docker volume ls. So that is what this point says. It says, isn't it? They are going to be stored independently. Okay, I deleted that particular thing, right? So it is nothing but the volumes are going to be stored independent of your containers. Right? Now if I go and you got volume. Now how you can do, where is this volume pointing to? Docker volume, inspect, volume ID. Right? You know your data is in this particular location. We'll copy it up. We'll say, okay, sudo. You have the container still with you. Making sense? So very important. So whenever you are going and working with Docker, your data should always be secured, right? Because if you basically remove that, what you say, data means anyway you are losing everything over there, right? Now how you can go and start, if you are starting the new container, you will say this is a volume to use, right? Making sense? So maybe like I'll stop it here today. Tomorrow we'll see how to basically start the container with the same volumes, and as well as we'll talk about mount points. Now if you see here, what is the disadvantage? You can't remember the source destination, I mean like source location here. It is somewhere where lib docker volume some specific name. You have something, tomorrow I'll discuss two more things. There is something called like named volumes. You can name the volumes. Now what is happening here, it is basically taking some ID, some specific ID it is getting up, right? So instead of that ID you can name those particular volumes. And apart from this, even if you name them, right, you will get some meaningful name, but still it is going with that huge location where lib docker data volume something something, your own directory. So let's say in your home directory you are creating something called like a volume 1 directory, or let's say if not something like Nginx website, you can directly point it. That is what data mounts, bind mounts. In that way you can give your own predefined things. Now that is very easy, because now you see that whenever you are updating the file system, it is automatically updating in your container also. If you are updating on the host, it is updating on the container. So if you are testing some websites, or let's say if you are testing some things, if you automatically change this in your file system, it is going to directly affect on your containers as well. So data mounts is very important concept. That's the reason. It becomes much easier to go and work with the data if you understand bind mounts or data mounts, right? So tomorrow we'll see like couple of things on this persistence itself, the data handling, right? And we'll try to go with something like MySQL, which is which makes more sense, right? Because basically in real time you always want to save your database more than your file system. Why? Because file system anyway it is going to be there in your GitHub. Anytime you want, git clone, data is there. But what happens to the database? If database is gone, you don't have anything like, what do you say, GitHub to store your databases. You are either storing the data as some tar file or something like that, and you'll bring it down. Right? Tomorrow we'll start with MySQL containers, something like that, which makes more sense and which would be like more easy to understand as well. Right? Today I'll stop it here.